Hello, my name is Chandler Gates. I'm a freshman at Hampton University, and today I'm going to be giving you a presentation on the Giotto spacecraft. The Giotto spacecraft was built by the European Space Agency. Giotto was the ESA's first ever deep space mission. The spacecraft's construction was led by British Aerospace, with instruments contributed by multiple European research institutes. It was one of the first major missions where a bunch of European countries came together to create a unified planetary science spacecraft. It was built as a cylindrical spacecraft about 1.85 meters long and 1.1 meters wide. It had a central load-bearing structure made from lightweight but strong materials, mostly aluminum and carbon fiber to withstand vibration during launches, and the dust impacts in the comet Halley. Because comets throw off dust and ice particles at high speeds, engineers had to design Giotto like a shielded tank. It had a two-layer Whipple shield on the front, the first for shattering dust particles and the second for absorbing whatever was left. This was important because it flew through debris at like 68 kilometers per second, which is faster than a bullet, mind you. It was also equipped with various scientific instruments like a camera system, dust detectors, mass spectrometers, magnetometers, and plasma and gas analyzers. I mean, I can go like on and on about that, but to keep it short, Giotto was built like a scientific tank, strong, shielded, and engineered to survive a high-speed drive towards a comet and send back the first ever close-up images of a comet nucleus. The Giotto spacecraft was launched on July 2, 1985, at the Giotta Space Center located in Kourou, French Guiana. The launch vehicle used was an Ariane 1 rocket. This launch put Giotto on the trajectory that allowed it to intercept Comet Halley during its 1986 return. This would be the first time modern spacecraft would meet the comet ever. Giotto's main target was Comet Halley, the most well-known periodic comet. After its successful encounter, the ESA extended the mission using a gravitational assist from Earth in 1990. Giotto was redirected to encounter Comet 26P in 1992, meaning that Giotto actually visited like two different comets, making it one of the only spacecraft in history to do this. Well, one of the only. When Giotto flew by Halley's comet, it became the first spacecraft to take clear images of a comet's nucleus. It also measured dust grain composition, monitored the jet activity of the nucleus, and measured the plasma and magnetic environment surrounding the comet. As for Comet 26P, it measured extremely low activity levels and collected valuable data on dust density and particle sizes. The Giotto spacecraft discovered that a comet's nucleus is extremely dark. It revealed that Halley's nucleus reflects only 4% of sunlight, which is darker than coal, by the way, and is covered with a crust of complex organic molecules and carbon-rich materials. In the end, the Giotto mission changed the way we understood what comets are made of and how they work. By being one of the first spacecraft to photograph a comet's nucleus up close, it showed us how much we've yet to learn, paving the way for future comet missions. Thank you for listening.